Next, we are going to talk about Databricks, and I'm happy to have Thorsten here with me today. So, can you shortly tell something about you and maybe also about Databricks as a company? Maybe not everyone here has heard about it yet.
Yeah, sure, and thanks for having me. So my name is Thorsten Jacobs. I'm a senior solutions architect at Databricks. We are based out of Stockholm mainly, so that's where I am. But in my case, I work with a lot of Finnish customers, so I just said I know Helsinki quite well by now. I'm here quite often, and Databricks. We are it's an American company based in San Francisco, and an innovator of a lot of technologies in the data sphere. And also the term Lakehouse, you might have heard, is something that Databricks really made popular. And now we saw a lot of other companies or others using the same term. There are a lot of technologies coming from Databricks. Spark, which is a parallel processing engine, which is really popular nowadays, was invented by the founders of Databricks. And then there are another number of other tools, for example, Delta, which is a storage format, which was invented by Databricks, which is now widely used at Microsoft, for example. They adapted it in their fabric now as well. MLflow, like a framework for machine learning, MLOps, which is open source. So Databricks really believes in open source. So all our tools are made open source. Now MLflow is one of the main tools for MLOps and has the same amount of downloads than like one of these really popular tools like TensorFlow, etc. Funny story. So a bit over 10 years ago, before the company was founded, Netflix had a challenge. And their problem was that they had a lot of data and they wanted to do AI on it. They wanted to have a recommender model to recommend movies to their customers. The problem was that at that time, for big amounts of data, you had like MapReduce, which was a technology which is quite difficult to use. Some of you maybe know that. There were warehouses, but warehouses don't really work well for machine learning. So they didn't really know how to do machine learning on so much data. So they had a challenge that they put out. And the challenge was basically, okay, how can we do machine learning on this large data sets? And then two guys from UK, from Berkeley University, in a short time wrote the first version of Spark to solve this problem. And then they handed it in. They came second in the competition, just because they got the same points, but they handed it in a bit later than the others. But that was how Spark was born. So basically, and then after Spark came Databricks. So without Netflix, maybe now Databricks wouldn't be here. So that's basically how it came all along.
Yeah, and the company is growing really fast, I think. So.
Yeah, it has been going quite well. So when I started a bit over 3 years ago, we were about 1,000 globally. Now we're over 5,000 people and expanding in Europe, in different regions. So it's going well.
Yeah. And when we talk about Databricks, we obviously talk about Lakehouse architecture, what you mentioned, and we at the Islet, I think most of the data platforms we are doing nowadays are Lakehouse architecture, is Databricks or Synapse Analytics based. But what actually is Lakehouse architecture? Can you explain? Maybe it's new to some people on the audience.
Yes, so the idea was basically, and that's in the name, to combine the best of two worlds of data warehouses and data lakes. And if we go back, data warehouses are still and have been like really popular tool for storing large amounts of data. And they're really good in it and running your SQL queries and getting your analysis from the data. But they have some limitations. They require structured data. So you have to transform your data to fit it into the warehouse. They mainly work with SQL, so it's a bit limited on what you can actually do with the data. And that's why some years ago data lakes came up. And data lakes allow for more modern data use cases to store unstructured, semi-structured data like text, IoT, log files, images, videos, all these kind of new types of data that arise. At the same time, they allow using like machine learning, for example, with Python-based frameworks, you're more flexible with what you can do with the data. But lakes also have their issues, especially when it comes to storing a lot of files in the lake. It gets quite messy. It's relatively slow to query the data. The governance is slow. The governance is difficult. And basically, these lakes became like swarms after a while. And then the idea of the lakehouse was basically to combine both worlds together. And this is basically our version of a lakehouse. And the idea here is that, I mean, first of all, Databricks runs on all clouds. It's fully a cloud-based platform. And the data remains in the lake. So you're fully owning the data. There's no costs for like egress or something. And then it's stored in a format called the Delta format I mentioned earlier, and that adds some functionalities that we usually only know from a warehouse, like transactions, like asset transactions. So if you have several people at the same time reading and writing the same file, it helps with these like scalability issues with governance. You can add fine like grained access controls. It helps with performance. There's like indexing, caching, like all these things that we know from warehouses, but added to a lake. And that's basically the first step of a lakehouse, to have one common data format, which allows to store all types of data, but at the same time also adds reliability, performance, and security, and these kind of things. And then the next layer would be then, okay, let's have a common governance layer on top of that, and that's our Unity catalog. And as mentioned before, governance on lakes usually was quite challenging, because governance means, okay, making sure the right persons have access to the files that see only the files that they should see, but also things like fine-grained access, that you only see specific columns or rows. Is possible with Unity Catalog, to get lineage, to understand exactly, okay, this table, what does it depend on, like further down the stream. So if I change something, what will happen? Where does it come from? So can I trust this data? Is it up to date? What are my sources? So this lineage is being added. Auditing is being added. You know exactly which user did what kind of operations. And that's Unity Catalog. And then on top, there is a separate layer for doing the compute, and basically for all kind of different users and use cases. And then you have a common data layer, a common governance layer, and a common interface for your users with the compute layer. And both, like the data and the compute, are scalable separately, so they're not coupled together. And then as a user, whatever I need at the moment, I maybe just have a small amount of data, I can do that. I have a large amount of data, I can do it. I want to do SQL, I want to do Python with machine learning, I want to do streaming. So all these are unified in one platform. And that makes it much easier, not only as a platform to build for the architects who do this, but also for users to collaborate, because then I don't have to switch systems, I don't have to switch file formats, send over copies, I don't have this silos, which we hear about a lot, because everything is in this common format. And it's an open format, as mentioned. So Databricks really believes in open source and in open formats. And there are a lot of other tools who can connect to the Delta format, so that you're not locked in. And yeah, so in short, Lakehouse is like using one platform for all your use cases, for all your data.
Yeah, makes sense. I would say. Hopefully, you all agree. You have released and published many new innovations. You already mentioned some of those, and Unity Catalog is one of the major ones lately.
Yeah.
Do you want to maybe open up that a little bit more, what it actually means and what are the benefits for organizations?
Exactly. Unity Catalog was one of the biggest new introductions like a year ago. It was it was finally fully introduced, and this is, as mentioned, this common governance layer on top. And it's, I mean, one of the things that I like about Databricks, we always have been good in seeing trends and like what is needed, what are the problems right now, and then reacting to that and offering solutions to it. And that's how the Delta format came along some years ago, because we could see, okay, there are these issues with lakes, with having a lake as a reliable data source, and then Delta came along. And then once companies then started to use their lakes and wanted to scale up, then the next problem became governance, making sure that the right user has access to the right files, as mentioned. And that's when Unity Catalog came in. And the idea there is that basically you close down the access to the lake to your normal users, and these users interact with tables. So the tables, that's basically metadata that is just pointing to the right location in your lake. But as a user, you don't have to think of data lakes. You don't have to think of what kind of access, like how do I get access to this file? Because especially thinking multi-cloud, many companies nowadays work multi-cloud. Each cloud has their different access methods. You have this credential pass-through methods. You have some roles like IAM roles in AWS. So as a user, it can be quite difficult to learn all this and know, okay, where should I save my files? And this, like Databricks takes this away by basically managing all what happens under the hood, saving the files at the right location, giving the right users access. And as a user, I only work with this this metadata, and Databricks then makes sure to give the right users access. And then plus, as mentioned, features like lineage, something that is also has been difficult to do, to really get like your end-to-end lineage of different files to understand the connection there. And then together with Unity Catalog, there are a number of new features that came. One of them is delta sharing. So if you want to share your data inside the platform with different users, that's quite straightforward. But maybe you have some users who are in a different cloud who are not using Databricks at all. And that's when this delta sharing comes in. So it's built into Unity Catalog, and you can create from a data asset a share, and then this share can be read by a subscriber or like a consumer on like in a different cloud, in a different tool. We have, and since it's an open format, we have, for example, connectors to Power BI, so you can just natively connect to this file, to Excel, even if you have a smaller table, to like pandas, notebooks, etc. And then based on that, there's also now something that we introduced, which is called the marketplace. So where you basically can also offer your data assets to other users, and they can browse what's available and get a preview, and then request access to it. So it's a whole package of how do I manage my data. So this is like, it's you don't have to use it, but it's a new feature, and it's really, once you start it, it really makes things much easier, especially for users who are already kind of coming from warehouses, who are used to work with tables, with access grants. They will feel home right away, and it will feel quite familiar to them.
Yeah, sounds good. And I think maybe another a bit technical question, but there is this Delta Live tables, and I think our Islet teams who are working with Databricks, they simply love it. So can you shortly describe what it is and why also our team loves it?
Sure. So Delta Live Table is our tool for building pipelines. So classically, you will have raw data in the lake. You will then maybe want to refine it a little bit, enforce some schemas, enforce certain like data quality measures, and then clean it up, maybe do some joins, etc. So you have different steps. That's what we call the medallion structure, like a bronze, silver, gold structure. It's basically just a concept of how you work with different stages of your data in your lake. And to build these pipelines, you can do it manually with code, but then we introduced data live tables, which helps making that much easier. So you define your transitions either in SQL or in PySpark code, and then data live tables will basically execute this for you, and it will give you an overview. You can see exactly like different stages of the pipeline. In case something fails, you will see where it fails and that you can rerun it. You get a log. You have auto scaling, so that and for those of you who don't know Spark, Spark basically allows to use a lot of the different virtual machines at the same time to work with the same data. So it massively can parallelize this data processing. And then it can scale up or down depending on, okay, how much do I need now for this specific data set? And it makes that in a smart way. But it also comes with data expectations. So you can, and that's important for like data quality issues and making sure that your data has the quality you need. So you can define freely expectations. This data should not contain null values. It should be in this range. It should not be older than 2000. And if then this data, some values come that are not in this expectations, then you have different options. You can just get a warning. You can quarantine this data and look at it later. You can stop the whole pipeline. And then that way you make sure that you can always trust the data that you have in your pipeline, and that your dashboards are like not failing, or like your machine learning model that expects a certain type of data later on is not failing. So yeah, basically adding these features to the pipeline. And the nice thing, as mentioned, is that with data live tables, even a user who has a warehousing background, who usually uses SQL, they can now write big data pipelines using SQL. So you don't have to learn Spark or something like that. And that makes it very versatile. But then in addition, I mean, you don't have to use it. We have users who are connecting external orchestrators like Airflow, like a DBT, something like that, to Databricks as well. So it's very flexible, but just gives an option basically.
Yeah, and we had our team's internal training and meeting, and one topic was doing streaming data with Databricks, and I think that was the shortest training ever, because I think doing batch loading, which usually means once a day or every 4 hours or something. So our guy just show it in the Databricks one click that now it's streaming. So that's the shortest training I have ever seen. But I think in Databricks it doesn't really matter. You can select the mode you want, do it stream or batch loading.
Exactly. Since all these things are natively integrated, machine learning is natively integrated, and streaming is natively integrated. You don't need additional tools. It integrates really easy. And as you said, for data live tables, there's a simple switch where you can say, okay, I want to run this on a schedule each night, or okay, I have a real-time use case, some IoT data, and I really need the data like updated fast. Then I just switch this to continuous mode, and I'm gonna have streaming data. So it makes it really smooth to work with. As mentioned, like this kind of new use cases inside Databricks, because everything is natively supported in the same engine. You don't have to switch. You use this for streaming. You use this for your batch operations. It's the same. It's the same thing.
Yeah. So lot of things here and what mentioned, but what is next? Next innovations now coming or coming later?
Yeah, there are a few interesting things coming, and yeah, for those of you also who want to know more, at the end of this month, we're going to have our Data and AI Summit in San Francisco, and that's usually the big event in the year when all the new announcements are coming. Some things to mention, right now, LLMs, like large language models, are a really hot topic with AI, with ChatGPT, and we released our own large language model called Dolly, which is an open source. Again, we open source this model that has a nice trade-off between being very powerful but not so still small enough to be able to own and train it yourself, because models like ChatGPT, they're so big, just one-time training costs actually hundreds of thousands of dollars. And this is like a smaller model that you can host yourself. Lots of integrations for large language model training inside Databricks. There is on the streaming side, we're going to introduce a new engine that is going to do this a bit faster. We recently acquired a company that works with data catalogs, and we're going to AI based, and we're going to integrate that with our Unity catalog. So there will be something like automatic tagging and classification of PII data, for example. So then if you have personal data somewhere in the lake, it will find it, it will classify it, and then you can hide that away from certain user groups. I think that was the main things that I there's more coming, but that's what
maybe later this year then, after announced.
No, there's, I just try to remember all these things, but these are kind of the highlights. And then a lot of small features, things that are being added that are better integrated, things that are being made easier. So right now, the thing with Databricks and Spark is it's a very powerful engine, but you have a lot of knobs to turn and to optimize and so on. And we're gonna make this more auto-optimized. In order to get best performance, what you have to do is you have to structure your data in the right way. And you do it in warehouses by building indexes. There are different methods, and the same you also do in a lake or with Delta. And then there will be more automation options that do that for you, so you don't have to be a Spark expert to get best performance. There will be serverless options coming. That's also one of the big things. So right now, the compute is run on virtual machines that you own that are in your cloud environment. But for some options, for some users, they don't need that. They just want a quick compute available in an instance. They don't want to think of, okay, which type of virtual machine should I pick? Let Databricks do that for me. And that's when the serverless comes in. So that within Click, you have a machine available for you in an instance, and then you can let Databricks decide what's the best machine for this kind of workload. So taking a bit of this burden away from the user.
Yeah, sounds really good. Maybe final question before closing. So I once got a call from our customer that they would really love to have Databricks, but how complicated is it to buy licenses from US-based company? So how can people buy Databricks? How it works? It's not that complicated, so
no, it's quite. It depends a bit on the cloud, but it's very straightforward, especially on Azure. Azure Databricks is actually a Microsoft first-party service, so it's fully integrated with all their other services, but also with their billing. And it's a Microsoft product basically with Microsoft support and everything. So you can just go in the portal, create a workspace, and you're ready to go with a pay-as-you-go model. We also have pay-as-you-go on the other clouds, but then there are also options to pre-purchase, to get a partnership agreement with us so that you can get more help from us, more services. But to just get started, it's really just one click. And from the user side, if you have users who are familiar with, for example, if you have data scientists, they like to work in notebooks, they like to write Python, R, and they will feel home in Databricks right away. If you have people coming from the warehousing side who like dashboards and SQL code, they will feel home in Databricks right away because we have an interface for that. For the Power BI users, very, very common, in especially for Azure Databricks, is that you connect Power BI to Databricks, and then as a user, because the data is in the Lakehouse, and then as a user, you're just using your Power BI as normal, but in the background, you have an engine that can work with really large amounts of data, that is in your lake, and can handle this data sets compared to usually like running things in memory, and then usually it's more the smaller data sets. So I think on that sense, getting started is quite straightforward.
Thank you.